chapter. Okay. So I want you to start on a new page in your notebook and update your content page. We are now looking at chapter 3. Approximation and estimation. Okay, so update your content page and your notebook. Start a new page. Okay, are we ready to start?
No.
No? Okay. Alright, don't need to copy anything yet. Okay, calm down. Ready? We start? Can I get some response? Can start already?
Yeah.
Okay. Right. So in this chapter, what we're going to be touching about or rather what we're going to touch on is actually on approximation and estimation. Okay. This will be the SLS lesson that will be shared with you for tomorrow, home-based learning. Okay. So there will be more things. Okay. At this moment, I'm still in the midst of editing. Okay. So that's why I haven't sent it out yet. Okay. But mainly for tomorrow, you'll be doing the last few sections of this SLS lesson. Right? So first thing, you need to clarify and understand what is approximation. Okay? And what is the difference to estimation. Okay? The idea of approximation and estimation is somewhat similar. Okay? At both instances, we will use the curly equal sign. Okay? So in approximation, it is about rounding off a number to give an approximate value. Let me just zoom in case for the back class. Okay, so we are rounding off the value. Okay, so for example, okay, someone Cheryl sees that bag that costs $42.90, and then she went back, okay, and then want to tell her friend, okay, Dorothy, that the bag actually costs about $43. Okay, so when she actually say about $43, it is actually like rounding off $42.90, okay, to the nearest whole number. Okay, so she didn't go and tell her friend the exact price, but kind of approximate it for her. Okay, so in this case, the number 43 is what we call an approximation of $42.90. Okay, so because 43 was actually rounded off. Yes, Vivian.
But in the situation where the bag costs $42.40, will you have to round half?
Okay, we're now not talking about rounding up or rounding down. We're just really trying to get an idea of approximation. Okay, so what Xavier said is that what if the bag is $42.40? Okay, then how do you share this information to your classmate? Okay, so normally what will you have done? If you want to go and tell your classmate that, hey, I saw this bag $42.40, but maybe you don't want to say $42.40 because maybe you saw it 1 week ago and then you want to approximate it for your classmate, what will you actually report?
$43.
$43? Who will say $42? Okay, some of you will say $42. How many of you will say $43? How many of you will say that it's free? No, I sure will say that it's free. Okay, so obviously it's not going to be free. Okay, so at this point it is really a personal preference, okay, in terms of how we want to go about approximating. Okay, but of course we do have rules when it comes to rounding off, which we have already learned in primary school, whereby if the number, okay, you're rounding it off to the nearest whole number, we look at the next digit to know whether we should round up or round down. Okay, so maybe for some of you, those that say it's $42, you have decided to do a rounding down, that's why you say $42. Okay, we do have the rules for rounding, but now we're just trying to get an idea about approximation. Okay, so next, estimation. So what is the difference? Estimating is like a guess, okay, guessing of a value known quantity. So I give you this example over here. I found this map of Singapore that shows us the population density. Population density is about how many people are there within that small area, okay, or that small distance. Alright? So somebody, okay, went mapped out, okay, our Singapore's population density and saw that this is what it is. Okay, the blue ones have 0 to 5,000 residents per square kilometer. So for every 1 kilometer square, there is about 0 to 5,000 people around the area. Okay, and then as the color gets different, let me just scroll down a little bit. Okay, as it gets darker, right, see that these small parts of Singapore, the population density is very high. We have about 45,000 per square kilometer. Okay, 1 kilometer square, how long would that be? Maybe about 3 classrooms. Why? 3 classrooms and then 3 classrooms by 3 classrooms. Okay, estimating around there. Okay, and there are 45,000 around the area. You can imagine how packed it is. Okay, so this map really shows how the population density is like in Singapore. And what if I want to estimate, okay, how much of Singapore's land, okay, is actually having a population density of 0 to 5,000. So we're just looking at the blue parts. How would you give a number to this? Any ideas? Any suggestion? Half of Singapore is about 0 to 5,000. Okay, anybody else has a different number? 65%. Okay, anybody else? Yes, Vivian?
About 3/4.
About 3/4. Okay, so at this juncture, we have Leon saying half, okay, Ethan saying 65%, and then after that, Xavier saying 3/4. These are really estimate, and they all have different rules when it comes to estimating. Okay, so maybe Leon, can you share with us how do you come to this idea of half? Okay. So you see, you will be based on this one. But we're looking at the area, right? Yeah. The blue parts as compared to the whole of Singapore. How much of the area is actually blue? So will you say it's still half? That's my question, you know. You say about 75%. So now how do you come up with this 75% number? It looks bigger. Okay, so we look at the appearance wise and then we give a number. I believe maybe for Ethan and Xavier also you get around that idea. Or maybe you just kind of like visually lump all these non-blue areas together and you think that okay, maybe it will fill up this part of Singapore. And then you see that maybe 2/3 of Singapore will actually be blue. Okay, so the idea of estimating can differ person to person. Okay, it really depends on individual. There isn't quite a right or wrong answer. But of course, if you want to tell me that maybe 1%, okay, of Singapore has a population density of 0 to 5,000, then 1% itself is a rather dubious number because clearly, I think the blue parts don't look like 1% at all. Okay, we can come up with a good estimate, okay, but the exact number we may not be able to give it. So that's the idea of estimation. Okay. Okay, so therefore, okay, these numbers that your friends have given are actually logical guesses by comparing the shaded area, okay, to the overall size of Singapore. Right? Now, what we're going to move on next is about rounding off, okay, whole numbers and decimals. These are things that we already know, okay, so I want us to just flip to our textbook. Let me just flip my textbook as well, okay. Okay, I want us to turn to our textbook, page 73. We just do a very quick recap, because this kind of things we learned in primary school already, huh? Okay, so now looking at practice now 1. Okay, Clarice. Clarice is you, right? Okay. So how will you round it off to the nearest 10? What will your answer be? 3, 4, 0, 9, 7, 2, 0, 3, 0. Okay, so Clarice gave us this answer. How many of you will agree with her? How many of you would disagree with her? Okay, so now presentation wise, okay, if I want to do this rounding off, how I need to present it is 3409 725. I approximate it to 3409 730. Clarice's answer is actually correct. Okay, just that we need to know how to go about presenting. Like I mentioned, presentation is very important. Okay, so how she got the answer firstly is to identify the tens place. Okay, and that is represented by the digit 2. Looking at the digit on the right of it, we choose to round up because it is 5 or more. So therefore 2 will actually end up becoming 3. Okay? Now, why do I need this 0 over here? It is for the purpose of holding the place value. Okay? If I don't have the 0, then this number ends up becoming what? 340,973. When right at the start we are looking at a number that is 3 million something. If you don't have the 0, it becomes 300,000 something. Okay, then it doesn't make sense already. Imagine you're supposed to have $3 million over in your bank, and then someone else go and estimate the money, okay, for you and say that you have 300 over thousand. Do you feel justified? You have $3 million in your bank, no? End up people estimate for you to be 300 over thousand. Okay, then you will feel that you lose a lot of money, right? Okay. So therefore, we present it this way. The red marking is not necessary. Okay, right there. What's also important is that we put brackets nearest 10 because that is how we go about rounding off. Okay. Then part B. With this number, we want to round it off to the nearest 100. What will your answer be, Joven? Joven is which one again? I'm sorry. That one is. Yes, Joven, can you tell me what will your answer be when round off to the nearest 100? Yeah, nearest 100.
3, 4, 10. What? No. 3, 4, 10, right? Like, no, it's 3, 4, 0, 9, 7, 2, 5.
3, 4, 10 ah?
100, oh, never mind, I thought it was
100. So,
3, 4, 0, 9, let's see this way by 10 here.
okay.
3, 4, 0, 9, 7, 0.
0, 0. Okay, great. Okay, so nearest 100 should be this. Okay, and then part C. Okay, with this number, how do we round it off to the nearest 1,000? Next person. Isan is not here. Kate. Nearest 1,000. 3409. 3410. 000. 000. Yes. Okay. So we get 3,410,000. Okay, because the 1,000 place is actually this number over here. Looking at the number on the right, we have to round up. So 9 round up becomes a 10. Okay, so therefore there is then addition 1 over here because 0 plus 1 becomes 1. Okay. Then after that, the remaining parts, the remaining places, we actually replace it with 0. Okay, and then part D is it, so this one nearest 1,000. Okay, Okay. For part D, we want to round it off to the nearest 10,000. What will your answer be, Joey? Sure? Nearest 10,000. Anybody disagree? Yes, Leah. Isn't this the same answer as me? Whether this one is the same answer as this one? Why you give up?
Like I said, this, yeah, like I said,
Yeah, so mine is my question, then you ask me back question.
I ask you whether that's right or not.
Okay, Mika actually raised her hand also. Do you think this was the answer you wanted to say? Or what was the answer that you wanted to say? Just now what Jovi gave is 3400000, right? Then Mika, what was the answer you want to give? 3410000. So Jovi, what do you think? Okay, so the wrong thing. Alright, so yes, no, yeah, you're right. Okay, so okay, the 10,000 place is over here, this digit 0. Okay, so then look at number 9, we have to round up, so that's why it ends up becoming a 1 over here. Okay, so I hope that we are clear about how we go about rounding whole numbers. Okay, next we look at rounding off decimal numbers first. So looking at practice now 2A, question 1. Okay, so practice now 2A, that is in your textbook page 74. We want to correct 78.4695 one decimal place, the nearest whole number, the nearest 100, and the nearest 0.001. Okay, so with these numbers, same thing the way we go about rounding. For the number 78.4695, how do we round it off to one decimal place? What will your answer be, Yen Hoi? Yes. What will your answer be if I want to round off to one decimal place?
Answer will be
78.5, probably. Can you give me a assertive answer? 78.5, okay. Right, do we agree? 78.5. Okay, so when we round off to one decimal place, okay, we can write in short form, put in brackets 1 dp. Okay. Next part B, we want to round it to the nearest whole number. Okay, what will your answer be then, Reese? What's your answer? 78. That's all. Okay, so rounding off to whole number, that will be 78. You're right. Okay. Anybody disagree? Okay, okay. Next part C. We want to round it off to the nearest hundredth. Okay, there is a TH at the back, very difficult to pronounce. Okay, so how do we go about rounding off the nearest hundredth? What do you think the answer would be? Let's choose someone, Velda. Do you recognize your 10th place and your 100th place? Okay, what would the answer be? Point, sorry. 47. Okay, great. So the 100th place for decimal numbers, sorry, 10th place, my bad. Okay, and then this is the 100th place. Okay, so we always start with the 10th when it comes to decimal. So we look at 6 itself. Next digit is actually 9 greater than 5. Okay, so therefore 6 will end up rounding up into 7. Okay, and this is to nearest 100. Okay, and then lastly to the nearest 0.001. Okay, what will your answer be? Joshua, you look a bit bored, so give me an answer to this, please. Nearest 100, nearest 0.001.
1,000. Or 3 decimal.
78, 47. Sure? Any else? 470. Okay, so Marcus says 470, whereas for Joshua he said it's 78.47. Okay, so let's try to think about this. Okay, the value of the number wise doesn't seem to differ whether there's 0 or no 0 or not. Correct? Okay, the value of number seems to be the same. Okay, but then because the question says to round it to the nearest 0.001, this is actually the same meaning as rounding off to 3 decimal place. And our third decimal place is actually at the digit 9 over here. Okay, and this 5 will cause the 9 to round up. Therefore, my 6 will have to end up changing into a 7. But then, to maintain the idea of 3 decimal place, I actually need to have the 0 over here. That is actually important to have. So you cannot drop the 0, otherwise your answer will not meet the expectation of nearest 0.001. Okay? Okay? So this one must have. Question so far? Okay. Next, we go back to our practice now 1 just now. You haven't looked at question 2 yet. Okay, let me just write down the question. I want you to read the question as well as I write. Now, this question, if we are told that we have this number 17,400,000 and this number was rounded off, okay, to the nearest 100,000. That means, right, this is after rounding. Okay, after rounding, this is the number that we're getting. We want to know before rounding, okay, what is the largest and smallest possible number? Okay, so we are trying to make a guess over here. What is the largest possible and the smallest possible before we round? Okay, so after rounding off, we must be able to get this. Okay, so that means that we need to think backwards. of it. Let me just write the number that we have over here. Okay? We are saying that we are rounding off to the nearest 100,000. The 100,000 place is this digit 4. Okay? And we know that it is a digit 4 based on the digit on the right of it to know whether we are going to round up or round down. Okay? So before we round off, so let me just write this here. Okay? We have a certain number in the 100,000 place, another number in the digit on the right, and then of course we have some other digits over here. These digits really don't quite matter in terms of our rounding. What affects our rounding is this digit over here. Okay? So let's say before, okay, this number itself, we actually rounded up in order to get to 4. That means that before that, this digit over here should have been a 3. Agree? Okay, so imagine a situation where we are rounding up. Okay? In order to round up, that means that my digit over here must be what digits? What are the numbers that are possible? 5 and above, right? So it is 5, 6, 7, 8, or 9. Agree? Okay? Yes. Can I haven't reached it? Yeah. Okay? So I'm just looking at the case of rounding up. Okay? So I'm trying to have the idea first. Rounding up, this is the situation we're looking at. Now what if we round down? Okay, I have not yet completed this answer. Okay? What if we are rounding down? Okay? That means I will still have my 17 over here. I have 6 other digits to fill up. If it were be rounded down, this digit over here should have been a 4. Correct? Now, what are the possible numbers that can fill up this space? What are the possible numbers that can fill up this space? 4 and below, right? Okay? So, because we are rounding down, so we can have 4, 3, 2, or 1. Right? Okay? The digits after that don't matter. Okay? Because it doesn't affect the way we do rounding. Alright? Now we go back to answering the question. We want the largest possible and the smallest possible. Clearly, just by looking at these 3 digits itself, we know that largest possible comes from rounding down. Because 4 is bigger than 3, right? Okay? And then the smallest possible will have to come from rounding up. Okay? So, largest possible, okay, which is a digit that we should place over here? If I'm aiming for largest possible, should put a 4, right? Okay? Because 4, 3, 2, 1, 4 is the largest one. Then we're looking for largest possible. What should my choices in the remaining spaces be?
9.
9. Very good. Okay? Then now, smallest possible. Let me choose this. Peter, what do you think should my smallest possible number be? 173 and what? 5 and then, sorry, suddenly blue. illogical in the first place. Okay? Next, we look at question 2 of practice now. Okay? Yep. Yes. Okay, let's look at practice now 2A, question 2. Okay, let's look at this question here. It says that when it says 8.395 is actually equals to 8.4 when rounded off to 2 decimal places. Because it thinks that 8.4 is the same as 8.40. So it's actually the same idea as what we had earlier on where Joshua thought of 7.4 or was it 740? I forgot.
78.47.
Yeah, okay. Then after that, Marcus thought of something else, okay? So in this case, okay, do we agree with this?
No.
We don't, right?
Yes.
Okay, because 8.4 itself is how many decimal place?
1.
8.4 is 1 decimal place. Am I just teaching Xavier only? I hope you all are on the same page, okay, with the type of response. So 8.4 is actually 1 decimal place. 8.40 is then 2 decimal places. So how do we frame this into our answer? So we need to write this out in words. Okay. So we first say that no, I do not agree. Okay, do not agree with me. So 8.4 is rounded off to 1 decimal place. Please spell this out in full. While 8.40 is rounded off to 2 decimal places. Okay, so we need to point out how one of it is that 1 decimal place, the other one is 2 decimal places. Are you copying anything down? Okay, any questions? Alright. Okay, no questions. I want to give you a piece of worksheet now. Okay, I hope that all the worksheets I've been giving you are being found inside your black file. Okay. Take one class now. Take one class now. on it, there is a document here. You click on that, okay, and it should open up to one of the tabs, okay. There are actually 4 tabs over here for my different classes. So this one is the one for you, okay. So these are the things that should already be in your file, okay. The later one, okay, that means the exercise 1A should be at the bottom of your file, okay, and then after that going upwards like that. Right, so now the latest copy that is in your file should be this 3.1 rounding and significant figures worksheet. Okay, for the content page, I will give it to you on a later date. So today is 15th Feb. Okay, so do keep track of what should be in your file. If you don't have the items, okay, then there's something wrong. Okay. Now, going back to the main thing, what we're going to cover now is about significant figures. Okay, let me just clean up the whiteboard first. I want you to follow through with me as I run through this. Okay, and then also fill out your worksheet. Now, firstly, what is significant figure? What is a similar word to the word significant? What does significant mean? Important, very good, okay? So, just like for example, if I want to describe my spouse, okay, my husband, he is also my significant other, okay, because he is important in my life, right? Okay, so the idea of significant is important, okay? So, we're trying to identify the important digits in the number, okay? And there are certain rules to it. So, therefore, we are going to be looking at when is a digit significant. Okay, I want you to come up with the 5 rules, okay, as I actually go through it. So the first thing that I will tell you, okay, as a clue, as an information, is that these 4 numbers over here, okay, they have this number of significant figures. Okay, so 192 has 3 significant figures. Xavier, can please don't do that. Right, 192 has 3 significant figures. 83.761 I have 5. 3 I have 1, 4.5 I have 2. Observing these 4 digits, okay, these 4 numbers, okay, what can you tell? How do we go about counting the number of significant figures? How do you think I counted the 3 significant figures? Yes, Xavier.
The number.
The number.
The amount of number.
The number of digits inside, okay? So, look at this number over here, 192. Okay, I count first digit, second digit, third digit, I get 3 significant figures. This one, I count 1, 2, 3, 4, 5, I get 5 significant figures. This one is only 1 digit, I have 1 significant figure. This has 2 digits, I get 2 significant figures. Okay, so it seems like, right, my significant figures is equals to the number of digits. So that's the idea that seems like we're getting, okay? But notice that these numbers here don't have 0 inside it, okay? What happens when there are zeros? Okay? So I'm telling you now that 1.09 has 3 significant figures, but then 0.00174 has 3 significant figures, and 0.0500 is actually 3 significant figures. Can you make a quick guess, okay, in deciding how did I go about counting the number of significant figures in these 3 numbers? Yes, Jazil.
Because in 109 there's a whole number at the front, so that means 0 and 9 do other significant figures.
Okay, and then?
And in front of 77 and 4, there's also a whole number, so that makes 174 means significant figures.
Okay. Okay, you want to share about this one?
Because even though there are zeros, 2 is a 0, in front of 2 zeros, there's still a whole number, which makes the 2 zeros 2 significant figures.
Which 2 zeros are 2 significant figures?
Zeros are
In front or the back? Back, is it? Okay, thank you, Jazil. Okay, let me share with you what Jazil just shared with me. Okay, the Okay, but I think that he did point out certain patterns over here. Okay, for the number 1.09, we see that the 0 is in between two non-zero numbers. Okay, two non-zero digits, 1 and 9 are not zero. So because it is in between, I count it as significant. Because there are 1, 2, 3 over here, I see that there are 3. But then, when it came to this part here, okay, I actually have 3 significant figures, and how I went about counting is that I count starting from the 1, 7, and then 4. If it is a decimal, okay, I do not consider the zeros at the front of the first non-digit number as important. So these are not going to be considered important. I start counting when I see a first non-zero number. Okay? So when that applies to our number 0.0500, likewise in the decimal, the number in front of 5, I do not consider this as important. Okay? So these are not important. What I do count is the numbers that come after the first non-zero. Okay? So my other 2 zeros over here are going to be considered 3 significant figures. Okay? So total of 3 as well. Okay? Any questions at this moment? So I want us to be clear about how we go about counting our number of significant figures. Question. Okay? If you have no questions, I want you to give this set of numbers a try. Okay? I give you 1 minute to think about it. Write your answer in the worksheet. Okay? Count for me how many significant figures should there be. Are we done?
Done.
Okay? In fact, I think 1 minute can be too long. Okay? Shall we check our answers? So 3.0024, how many significant figures are there? What is your answer? Let's pick one person. Danish. Sorry? 5. Great. Okay, there are 5 significant figures in that number. Next person, Marcus. Next one.
Yeah.
How many significant figures?
5.
5. Okay, so we start counting from this one. 1, 2, 3, 4, 5. Okay, where's this one? I count these digits here. Last one, 0.10. How many significant figures are there, Ian? 2. Okay, so we count this one and this one. So there are 2 significant figures. Okay? Alright. Questions? Next. Okay? Remaining numbers. Can you give me the answer? Huh? I'm playing this.
No, are we playing bingo because there's one more line of 3 already?
No, we're not playing bingo.
No.
But it's a good idea. Maybe next time I can play bingo with my friends, with my students. Okay, how many significant figures are there for these numbers? I know your mind all thinking about me already, right? Is it after this me?
Yeah.
I see your eyes all saying the same thing, looking at the clock and all that, but too bad, your whole me time, okay? On here, 5,062. How many significant figures are there? 4. Great. Okay. Next one, 0.06032. How many? Ricky. This one. 4. Okay. Next one, 6.090. Yuki. How many? 4. Okay, great. And then 70.8001 Genevieve. How many? 6. Okay. Last 2. Jude is not here. Mia. 2. Okay, for this one, yes. And finally, 41.0320 Ernest. You sure? Huh? 5 or 6? You don't know. How? Okay? We count this as significant. The non-zero one we must count. Okay? This one in between the non-zero we must also count. 3, 2, I must also count. The 0, okay, since we already intentionally put it there, we must also count. Otherwise, I would have not put it one. Right? Okay? But since I intentionally put it there, I must count it. So therefore, there are total of 6 significant figures. Okay? Questions? Alright? Question? Yes. You want to go toilet? Okay, then you better go back and copy. Okay, these rules. Alright, so these are the 4 rules that I've covered so far. Okay? You can go toilet. I'm not sure. Okay? The rest of you, I want to fill in the blanks in your worksheet. Okay, for these 4 rules that we have covered.
So next time pick Xavier.
Pick Xavier.
Yeah, I never got pick before.
It's okay, you always pick yourself.
But I can pick.
You raise your own hand.
No, it has to be. It's kind of good because.
Can I short form? What thing short form?
That's what I said, but not
People. I mean, okay, this is for your own notes. So long as you understand can already. Okay? Exam is not going to test you to write down these rules. The exam will test you how to count. That's all.
Everybody around me are playing.
Okay? We done? Before you copy, I give you worksheet already. Hello? Here? Okay. Okay, are we done? Need to speed up your writing, Moving on. Okay, Joshua, make sure you copy from Ethan. Done? Okay. Now, okay, there's still a 5th rule I have not yet covered. Looking at all these numbers over here, we notice that they are mimic decimal numbers, okay, and we look at how zeros are like in decimal numbers. We have not yet covered what if I have a 0, okay, in a whole number itself. Okay, so what is going to happen? So our question over here is, what if the zeros are at the end of a whole number? Do we count all those zeros as significant or not? Because we know that when we were doing our rounding off, okay, when we were doing our rounding off itself, some of the zeros are there for the purpose of holding the place value, in terms of making it still remain as a 10,000 over number or 100,000 over number. Okay? So these are some of the numbers I want to use as an example. Looking at the first one, 3,796 meters. If I round off to the nearest 10 meters, okay, my blue digit over here, the 9, I will have to round up. Agree? Okay? In order for me to actually get 3,800 eventually. Okay? Because 9 round up become 10, 7 will become 8. So in this process of doing my rounding off, I actually took this, okay, to round up. So I was looking at up to this place over here. Okay, so I need to count 3, 8 and this 0 as significant. The last 0 over there is solely there for place value purposes. Okay, for place holding. That's why I do not need to count that last 0. So when it comes to whole numbers, it is not all zeros that we need to count as important. We must look at the context to that the question asks us to round off to. Okay? You understand? Alright? So, there are these two other examples, okay? And then after that, this is the rule, right? Looking at how your classmates are already there waiting for you all to go to PE with him, okay? Not to PE with them, right? Okay? So, these remaining two examples, I will put it up as a video, okay, for you to watch for home-based learning tomorrow. Okay? Any questions? Don't need to rush to copy. Tomorrow home-based learning, you can do it up.